The final thing that we're going to look at is applications of cosine law. So when we're looking at this, all we're doing is just setting up a triangle. We're looking at what the information is giving us and then realizing that we don't have a right angle or we don't have a complete ratio. So when I'm looking at this triangle here, I'm looking to see, do I have either a right angle, which in 700 BC, we've got engineers that are creating a tunnel through Mount Castron to bring water from one side to the other. There's nothing actually in the question that gives me any information other than the diagram that's given. And that's the important thing, that for this one, all the measurements are shown below. But when we're looking at this, we're looking, do we have a complete ratio, which here we don't, and we definitely don't have a right angle. So what that's gonna say is we need to make something like this. So we've got A, B, C. So I'm just labeling the triangle so that I understand what I'm finding. I'm gonna have A squared equals B squared plus C squared minus 2BC cos A. And now I'm just gonna substitute everything in. A squared equals 5,000 squared plus, 5,500 squared minus 2 times 5,000 times 5,500 times the cos of 10. Now we're gonna go through, and I would do this backwards if I was doing it. So I'm gonna do cos 10 times 5,500 times 5,000 times 2, and I'm gonna get something like this. And I'm not gonna have a decimal here. These numbers are all very big, so all we're gonna do is just round to the nearest whole number. We would get 541,64426. Now I'm squaring 5,500. So I'm gonna have, actually I'll square 5,000 first. So we get 2, 5, and 1, 2, 3, 4, 5, 6, plus 3, 0, 2, 5, and then 1, 2, 3, 4. All we're gonna do that's a squared. We'll put all that together. So a squared, it's gonna be 108,557, let's call it 4. And then we're gonna square root that. We would get A is gonna be around this. Therefore, the tunnel is 1,042 meters. Again, when I was doing this, I didn't round until the very end. I did round, obviously, when I was writing the numbers down, but I didn't round my answer until the very end. I left everything in my calculator. I worked from right to left. I worked this way down this line. Okay, so I worked from right to left. Some of your calculators will allow you to see it the whole time, some won't. It depends on what you have. You need to get used to your calculator. So when to use SOHCAHTOA? So SOHCAHTOA is right angle triangles. Okay, so actually let's do this. So SOHCAHTOA. Right angle triangle. Sine law, cosine law. So we've got right angle triangles as SOHCAHTOA. You can also use Pythagorean theorem. Okay. Sine law and cosine law. So sine law is when we have a complete ratio. So we have theta and x. So if those two are given, and then we're given any other piece of information, we could be given another side, we could be given another angle. Let's just call it A. Okay, whatever you're given, as long as you're given one of the other ones, we can find everything else. If we're given the other angle, we can do 180 minus our two angles to solve. If we're given another side, we can then solve our angles using sine law. Okay, sine law, you need to have that complete ratio though. That's super important. Cosine law We don't have a complete ratio, but we do have side, angle, side, or, and in this case, you'd be solving for x, or you could have side, 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 and then you could solve for any of the angles. In both of these cases, there's no right angle.